Assalamu alaikum. This is the second part of this week's lecture. It's about the range and endurance. So just look at this. Okay, this is the cruise mode. We have two types of cruise mode. Actually, various types, but what we are going to discuss now is only two types. One is the constant airspeed mode. Another one is constant altitude. Okay, so there are two types. Let's look at the first one. Okay, you must get the idea first. Let's say the aircraft is cruising at altitude h. Okay, with the initial time of t naught. Okay, initial displacement s naught. Initial altitude h naught, initial airspeed v naught, okay, and initial weight, okay, this is big W, so initial weight, okay, W naught. Now, as it cruises, it gains range and endurance, okay, so it consumes the fuel, okay, it burns the fuel, and the aircraft is getting lighter and lighter. Okay, it's getting lighter. Now, for the first case, we assume that the velocity is constant. So, if the velocity is constant, as the aircraft is getting lighter, it must climb up because the speed remains constant, the CL is constant, coefficient of lift is constant, but the weight is less. It's getting less. So since it is getting less, it will climb up. So in the first case, let's imagine that it climbs up at angle gamma, which is quite small. Okay, it will climb up, and after a certain period of time, okay, after certain amount of range, it will arrive at a certain destination at time t1, displacement s1, altitude h1, so it will gain the altitude, but the velocity remains constant. So v1 is equal to v naught. Okay, it is constant, but now the weight is different. Okay, w1 is less than w naught. Okay, so the difference in weight is the amount of fuel it is consumed. Okay, that is for constant airspeed mode. So what happens is that the weight is decreased, okay, but your airspeed remain constant, thus you need to climb up. Okay, that is number one. Number two is for constant altitude mode. Is that your time, okay, initial is t naught, but later on is will be t1. The altitude h naught and the altitude after cruising remain the same. Okay, they're both the same. The altitude is constant. So since the altitude is constant, okay, you don't allow the aircraft to climb up, but then the weight is reduced. Okay, remember that the weight is reduced because the fuel is consumed. So by that, the aircraft must slow down. Okay, to remain at the same altitude, it must slow down. So the velocity v1 will be less than v naught. Okay, so in this case, the gamma will be 0, altitude is constant, and we're going to derive the first one, the constant airspeed mode. Or is it constant altitude mode? Which one? Okay. Yes. We're going to do the easy one, the constant altitude mode. Alright. So let's look at the constant altitude mode. Okay. So now you know that gamma is equal to 0, h1 is equal to h naught. Okay, it is constant. Now you need to find what is the range and endurance. We need to derive this equation. Okay, so let's look at the first one. The change of aircraft weight is due to fuel consumption. So aircraft weight is changing because of fuel consumption. So as time is increased, your weight changes. Okay, so dw over dt, and this is equal to the negative ct times thrust available. Okay, this is a thrust available, or the thrust. Okay, so ct is thrust specific fuel consumption, tsfc, times thrust available. So you rearrange this, it will become something like this. Now, will thrust available be maintained? Yes. Okay, or no? Let's find out. Okay, now then we do integration. Okay, from t0 to t1 over dt, so we get the time difference. This will become an endurance. Okay, and we do the integration from weight, okay, initial weight into the final weight, okay, over dw, negative dw over ct times ta. Now the thrust available, okay, since this is constant velocity, is it? No, constant altitude. Sorry, it's constant altitude. So not only the weight changes with time, but also the thrust available will change with time. Okay? Because you have to fly slower, right? You have to fly slower as time goes by. So as you have to fly slower, your drag also will reduce. Okay, will be reduced, and thus the thrust available, you must reset your thrust to be equal to the drag, so your thrust will also be reduced. Okay, when your thrust is reduced, okay, your fuel consumption is reduced, but not specific fuel consumption. In specific fuel consumption will be the same. Okay, now again, the throttle is set so that the thrust available is equal to the thrust required, which is equal to the drag, and weight is equal to lift. Okay, there is no change in altitude, so the weight is equal to lift will remain the same. So this equation then will become this. Okay, this equation. Okay, where you get this is 1 over thrust available. Okay, so 1 over thrust available equal to drag, weight equal to lift, and now it becomes this. You do this integration. Now assume that ct is constant. Okay, and cl over cd is the lift to drag ratio. So based on this is constant. Okay, now we have function of weight now here. Now we do integration of this equation over dw, and we get the endurance, which is this one. So the endurance is equal to 1 over ct, okay, cl over cd, or l over d, okay, natural log w0 over w1. So if you want to fly, okay, longer, okay, if you want to fly longer at long time, right, not range, fly at maximum lift to drag ratio, this part. Okay, and this is only for jet aircraft. Okay, not propeller driven, but jet aircraft. Okay, now how about range? Now to do range, you have to look at the kinematics. Okay, the change of displacement is velocity times the change of time, and we recall that dw over dt is equal to this. Okay, dw over dt will be equal to this. So where does it come from? Okay. Now we find, you know that this dt is equal to dw over negative ct times thrust available. So we replace this dt with this. Okay, with this part. Okay, I'll maintain the v here. Okay, now we have equation in terms of ds. Okay, or ds in terms of dw, in terms of weight. So we do integration of ds. This thing we get range. Okay, definition of range, and this part. Okay, we integrate from w0 to w1. So now we get the range equation. Okay, is equal to this. Now again, thrust available is equal to this. Okay, cl over cd times w. Okay, So this is thrust available. This is V, this is CT, this is maintained. Now remember, at this condition, is velocity, okay, is not constant. Okay, velocity is not constant. So velocity is equal to weight divided by half rho s CL. Okay, CL. So I have made a mistake here. Now this is not 2. This is wait, yes. I buang half. Okay, that's make more sense. Okay, so tak ada half dekat sini. So sebab actually half ni naik atas jadi 2 ni. Okay, faham lah. So now you gantikan ini masuk dekat V ni. Okay, put it inside this V and you get this equation. Now then kita boleh integrate. Okay, and integrate, you get this equation. Okay, nah 2 dengan 2 ni cancel lah. No, tak cancel. Oh, okay, now this is equation of range. You check back here dekat textbook. Okay, so let's look at the textbook. Okay. Under Brigade formula for jet aircraft. Okay, this is range for propeller driven. For jet airplane, it's under 613. Okay. This is the equation endurance yang saya terangkan tadi, and this is the range equation. Okay, so bismillah, because about this one, yeah. Okay. So this one is the equation of range. So for range, to achieve maximum range, you have to fly at maximum CL to the power of half over CD. Okay. So to achieve maximum range, so not maximum lift to drag ratio, but maximum CL to the power of half over CD. So that's the reason why we are looking at that in the cruising. And you have to fly at the highest altitude possible, where your rho is the smallest, and your wing, okay, shall be the smallest also. And so for jet aircraft, you tak perlu wing yang terlalu besar. Okay, no need to have big wings, just enough to lift it up. Okay, enough to lift it up. So to go far, so sebab itu tengok airlines, wing dia slim-slim je, ujung slim-slim je. Dia tak berapa besar sebanding badan dia. Still besar, but tapi tak adalah wing dia terlalu besar macam kalau terbang zaman dulu, tak. Okay, slim. And of course your specific fuel consumption mesti serendah mungkin, but that is another problem, the problem propulsion. But untuk performance, fly at this condition and get the maximum range. So meaning that kapal terbang yang terbang lama, okay, dengan kapal terbang